Hey guys, are you confused about what excess is and how to find excess? Well, I hope by the end of this video, especially as we reach the last example, I hope you'll be able to do it yourself and you won't be confused anymore. Now, let's just go through a general concept first before I get into the examples. If you want to skip to the examples, then you can just skip to the next chapter. Now, let's say we have reactant A reacts with reactant B to form AB. And let's say we had 3 particles of B and we had 5 particles of A. Now from this, when you think about it, we can only form 3 molecules of AB. Only 3 products can be formed because only 3 particles of B exist. Although there are 5 particles of A, only 3 particles of B exist, and therefore the most product that we can form, the most amount of product that we can form is 3 particles of AB. So from here it tells us that A, there will be extra, but B will be completely reacted. So these are some keywords here. When B completely reacts with A, there will still be 2 particles of A extra left over. Now this is when we say that A is in excess. There is extra of A, whereas B is known as the limiting reagent or limiting reactant sometimes. So this is the limiting reagent and A is in excess. So this is the concept of excess. After it has completely reacted with the other reactant, if there is extra, if there is some left, then it is in excess. If everything is used up, it is completely used up like B here, then it is the limiting reagent. Now let's get to the examples. We have sodium reacting with chlorine gas to form sodium chloride. When we are dealing with any calculations in chemistry, we must begin by ensuring that the chemical equation is balanced, because a balanced chemical equation will tell us the mole ratios of the reactants and the products. But if it is not balanced, then we cannot obtain the mole ratio. So first, what do I mean by mole ratio? When you balance the equation, we balance by putting a multiple in front of each species. For example, 2 here and 2 here. And in front of chlorine, there's nothing, which means it is actually 1. It is not 0, it is 1. So this 2, 1 and 2, these are what we call the mole ratios. When we look at this equation quantitatively, we can say that generally 2 moles of sodium would react with 1 mole of chlorine to produce 2 moles of sodium chloride. So this is how we get our mole ratio. And we are going to use this mole ratio, this general ratio of reaction. Then we are going to use that and put in our specific number of moles and figure out which is in excess and which is the limiting reagent. Now let me show you what I mean. So first we start with the mole ratio of sodium to chlorine. So the question here is to find out which is in excess, which reactant is in excess. So when we see sodium reacts with chlorine in a ratio of 2, so where do I get this 2? From here to 1, here, 2 to 1. 2 moles of sodium would react with 1 mole of chlorine completely. This is for a complete reaction. So this is just the general ratio. Now, how much of sodium is present, how much of chlorine is present? So the question has given that there are 2 grams of sodium and there's 2 dm cube of chlorine. So we have the mass of sodium and the volume of chlorine. Now it is very tempting to go, so now we have 2 to 2. But this is wrong. This is not right, because we have to remember that the 2 to 1 here is a mole ratio. This is a mole ratio. And therefore, we can only use moles, number of moles. We cannot use mass, we cannot use volume, and we cannot use number of particles. We can only use moles. So, in 2 grams of sodium, how many moles of sodium are there in 2 grams of sodium? So we have to go back to our 3 formulas of moles, which you cannot forget when we are doing chemistry calculations. So mole is equals to mass. The relationship with mass is the mass over the molar mass of substance. It is also the volume over the molar volume of a substance, and it is also the number of particles over Avogadro's constant. If you guys want me to make a video on this mole concept, then please comment down below. I will definitely look at it. So let's look at this. Now we are currently dealing with the mole ratio. We want to find how many moles of sodium there are in 2 grams of sodium. So we use the relationship between mole and mass, that is mole is equals to, let's do it at the side here, moles, the number of moles of sodium will be equals to the mass of sodium over the molar mass of sodium. So where do we get the mass? The question has given us that the mass is 2 grams, so we use 2. Now where do we get the molar mass of sodium? So the molar mass of sodium has the same magnitude as the relative mass. It does not mean the same thing, but the magnitude is always the same. So the relative mass of sodium, sodium is an atom, so relative atomic mass of sodium we can find from the periodic table. It's usually given in the questions. Here it is given as 23. Alright, so this relative atomic mass is 23, which means the molar mass of sodium is 23. So here we will get the number of moles of sodium is equals to 0.087 moles. So now we found the moles of sodium. Now that we have the actual number of moles of sodium that are going to react, then we can find the moles of chlorine that reacts completely with this number of moles of sodium. So how do we do that? We use the mole ratio. So the moles of sodium that's actually reacting is 0.087. So this should react with, now we need to find how many moles will react with, how many moles of chlorine will react completely with 0.087 moles of sodium. Now if you are very familiar with ratios, then you can do it immediately, but if you are not too sure, don't worry, we can just use 0.087 over x, which is this ratio, is equals to 2 to 1, so 2 over 1. So you can just use this method and find the moles. So you will find that x is equals to half of 0.087, which is equals to 0.044 moles. Now we found the moles of chlorine that completely reacts with 0.087 moles of sodium. So it is 0.044 moles. So now we still need to find the moles of chlorine that are present. To find the actual number of moles of chlorine, we are given the volume of chlorine. So we have to use the relationship with volume. So moles is equals to the volume of chlorine divided by the molar volume of chlorine. So the volume of chlorine is 2 decimeter cube as given to us in the question. Molar volume at standard temperature and pressure is 22.4. So divided by 22.4. Now this will give us an amount of 0.089 moles of chlorine. So there are 0.089 moles of chlorine that is actually there. This is the actual number of moles of chlorine. So let's write that down. Actual number of moles. So now we need to compare this with the number of moles of chlorine that would react completely with the amount of sodium present. So let's just do that. So this is the amount, this is the actual number of moles of chlorine present, 0.089. However, only 0.044 moles, as we counted earlier, only 0.044 moles of chlorine is going to react completely with all the sodium that's present, that is 0.087 moles of sodium. So again, only 0.044 moles of the chlorine that's present will react with sodium. But we have 0.089 moles of chlorine that's there. That means after the 0.044 moles has reacted, there will be extra chlorine that's left. There will be some chlorine that didn't react. So since there is a balance of chlorine, there is extra chlorine, then chlorine is the one who is in excess, and that would make sodium the limiting reagent. So in our reaction here, let me just clean that up. In our reaction here, chlorine is in excess and sodium is the limiting reagent or the limiting reactant. So this is how we find excess and limiting reagent. Now the amount of product formed, so how much sodium chloride is going to form depends on which reactant has reacted completely, because we cannot take the reactant that has excess. So because the extra amount is not going to react. So if we want to find out the quantity of sodium chloride formed, we have to base it on the number of moles of the limiting reagent, sodium. Only this will give us an accurate picture of how much sodium chloride is formed, because sodium is the one that reacts completely. Chlorine will still have extra after the reaction is completed. So we cannot use reagents in excess when we want to find quantities of either products or reactants. We can't use the reagent that is in excess. We always have to use the one that is the limiting reagent. Now let's try another example, one more example. Let's look at this reaction. We have magnesium. Magnesium reacts with zinc chloride to produce magnesium chloride and zinc. So this is a displacement reaction. So first thing we need to do is check if it is balanced. So let's check if it is balanced. Look at the number of atoms on the left and the right. So if they are the same, then it is balanced. In this case, it is balanced. So this is done. Now we can look at the quantities given to us. There's 32 grams of magnesium and 85 grams of zinc chloride. Now it is tempting to think that zinc chloride is in excess because it is more than double the weight of magnesium. But remember, we have to compare the number of moles, nothing else. No other quantity should be used. You cannot compare the mass, you cannot compare the volume, you cannot compare the number of particles. Although there are some exceptions there, but to avoid any confusion, always go back to moles. So here we have magnesium and zinc chloride. The mole ratio is 1 to 1. There's no number in front, which means it is 1 to 1. So magnesium to zinc chloride, the mole ratio of the reactants is 1 to 1. 1 mole of magnesium will react completely with 1 mole of zinc chloride. So now again, we cannot use the mass, we need to use moles. So let's find the moles. The moles of magnesium. So once again, we are using mass. So we use the relationship between mole and mass. So mole is mass over molar mass, which means the moles of magnesium will be equals to mass of magnesium over molar mass of magnesium. Mass of magnesium is given as 32 grams. Molar mass will also be given as the relative atomic mass. So molar mass of magnesium is 24. If it's not given to you, you can refer to the periodic table and find the mass number. So the molar mass here is 24. This will give us 1.33 moles of magnesium. So this is the amount of magnesium, this is the moles of magnesium that is reacting. So let's find the moles of zinc chloride first. Before we find what is the moles that will react completely, let's find the moles that are actually there. It doesn't matter which you do first. So the moles of zinc chloride here is 85 grams. So this will be mass over molar mass again. So here we will take the mass of zinc 2 chloride, which is 85, divided by the molar mass of zinc chloride. So now here we have a compound. Now when we have a compound, how to get the molar mass of the compound? Again, the molar mass will have the same magnitude as the relative mass. They have the same magnitude. Since we have a formula unit here, we will have to take the relative formula mass of zinc chloride. How do we take the relative formula mass? By adding together the relative atomic mass of all the elements present. So we have 1 zinc. So let's take down the relative atomic masses first. So for zinc, the relative atomic mass of zinc is 65. Here, zinc is 65 and chlorine is 35.5. So zinc is 65. There is one zinc atom here, or rather it's an ion. So this is 65 plus 2 chlorine ions here. So the mass of the ion will be the same as the mass of the atom because the mass of the electron is negligible. Alright, so this is 35.5 times 2. When we work this out, we get 0.625. 0.625 moles. So these are the moles that are actually there. These 1.33 moles of magnesium is in the reaction, 0.625 moles of zinc chloride is in the reaction. These are the moles that are actually present. Now let's find out how many moles of magnesium would react completely with how many moles of zinc chloride. So you can start with either one. So I'm going to do both here. So let's start with magnesium first. So the ratio of magnesium to zinc chloride is 1 to 1 here. We have 1.33 moles of magnesium that is actually reacting. So 1.33 moles of magnesium would react completely with 1.33 moles of zinc to chloride because the ratio is 1 to 1. 1 to 1 means exactly the same amount. So the amount of zinc chloride that would react completely with the magnesium that is present is 1.33 moles. However, the actual amount of zinc to chloride present is 0.625 moles. This is what is actually there. This is the actual number of moles. Actual number of moles. So let's compare the two. The actual number of moles is 0.625, whereas 1.33 moles of zinc chloride is needed to react completely with 1.33 moles of magnesium. So the amount that would react completely, this one is the amount, is more than what is actually there. So which means what is actually there is not enough. It is actually not enough. Because in order for magnesium to react completely, it has to react with 1.33 moles of zinc chloride. However, we only have 0.625 moles of zinc chloride present. So there is not enough of zinc chloride, which means zinc chloride is the limiting reagent because there's not enough of it, whereas magnesium would be in excess. So let's do this the other way around. Let's look at the amount of, let's start with the amount of zinc chloride. Alright. So in the same way, zinc chloride to magnesium has a mole ratio of 1 to 1. When we start with zinc chloride, 0.625 moles of zinc chloride will react completely with 0.625 moles of magnesium. So when we look at this, the amount of magnesium that would react completely is 0.625. However, the actual amount of magnesium that is there is here. This is the actual amount. Actual number of moles is 1.33. So in this case, the actual number of moles is more than the amount that reacts completely. So when we compare the two, the actual number of moles is more, and therefore after 0.625 moles of magnesium has reacted completely, there will still be a balance, there will still be extra. This means that magnesium is indeed in excess. So there are two ways that we can look at it. If you compare the actual number of moles present and the number of moles that would react completely, right? So let's make a general statement here. If the actual number of moles present, actually what is there, is more than the moles that reacts completely, then this is in excess. This reactant is in excess. So the conclusion here would be the reactant is in excess. Reactant in excess. There's more. Even after reacting completely, there will be some left. So the reactant is in excess. Let's say that it was the other way around. The actual number of moles is less than the moles that reacts completely. So if the actual number of moles is less than what would be required to react completely, then we can conclude that the reactant is the limiting reagent, because there's not enough. There's not enough of it. It is less than what is required to react completely. So this becomes the limiting reagent. If this video has helped you, guys, I would really appreciate if you would just hit that like button. It's free and it only takes 1 second, so please help me and hit that like button. It really does help to contribute towards my channel. And if you like more videos like this, then you can subscribe. I'll be producing at least one video a week. I'll see you in the next video.